Hi everyone, I'm going to discuss basic probability. So before I begin, let me discuss some important terms which are needed in our discussion. Probability, when we say probability, this is the chance that an uncertain event will occur. Now, the probability value class is range from 0 to 1. So if the probability value is zero, meaning the chance that the event will happen is impossible. On the other hand, if the probability value is one, meaning the chance that the event will happen is very certain. Event in probability is described as each possible type of occurrence or outcome. For instance, if we are dealing with a standard deck of cards, there are 52 cards. So each card there is considered an event. Another is when you toss a fair coin. So each outcome from a fair coin is considered an event. Now, a head is considered an event, while a tail is also considered an event. We have the what we call simple event, and a simple event is an event that can be described by a single characteristic. Like from a deck of cards, you describe a card by one description. For instance, a red card is a simple event. A black card is a simple event. A face card is a simple event, meaning you just describe the event by a single characteristic. So that will fall under simple event. Now, the sample space class is the collection of all possible events. So the total number of elementary outcomes. Like I've mentioned about a standard deck of cards, there are 52 cards from standard deck of cards. So the sample space there is 52. From a fair coin, the total outcomes is 2. So the sample space is 2. From a fair die, we have 6 outcomes there. So the total space is 6. Now, we have mutually exclusive events. So, events that cannot occur together are mutually exclusive events. For instance, a black card and a red card are mutually exclusive events because they cannot occur together. So, when you select a card, it can never be a red card at the same time a black card. So, the two are mutually exclusive events. We also have the what we call joint event. And joint event class is described by more than one characteristic. When you say a red card at the same time an ace card, so you describe that event in more than one characteristic. So we consider that as joint event. Another is, um, for example, in a survey that you conducted, so you have a group of male and female respondents, and then they have to answer questions like yes or no questions. So we can say that a female at the same time who responded yes is a joint event because we describe the event in more than one characteristic. First is female, and then a respondent also who answered yes. So we describe that event in more than one characteristic. So we consider that as a joint event. Now, there are three ways of assessing probability, of computing probability. When we compute when we work on priori classical, this is about our prior knowledge. So if you have this prior knowledge and you are working on the probability, so this is about priori classical. For example, it's our prior knowledge that there are 52 cards from a deck of cards, and we are calculating the probability as we select a card from the 52 cards. So anything related to that, we are assessing a priori classical probability. If it deals with observed data, this is about working on empirical classical probability. Like you have a set of data, a result of data from a survey, then you want to calculate probability involving that observed data. So this is about empirical classical probability. Now, with subjective probability, this is biased because the probability is based on the opinion of the one working on the probability. Like, for example, a student was asked by his mother on his chance of passing statistics, and he confidently replied 100%, meaning that student is very much confident that he will pass statistics. On the other hand, if the parent would consult the statistics teacher on the chance of his son of passing statistics, and the teacher would say 50% your son will pass. So it's not that very sure that the student will pass. So subjective probability will come up with a different probability value. So there is no such formula given to that because this is based from an opinion. So in the next slide, we will be calculating on the probability, basic probability as regards to a priori and empirical classical. So for example, a card is drawn from a standard deck of 52 playing cards. Find the probability that this is a black or a red card. So take note that we have made use of the conjunction or here. So this is like calculating on the probability of selecting a card which is a black card or a red card. So when dealing with probability of selecting a black or a red card, we have to identify first the probability of selecting a black card. And then we have to find out as well the probability of selecting a red card minus their joint probability, black and red. Now, how do we know the chance or the probability of selecting a black card from a deck of cards? So we should know how many black cards do we have from a deck of cards. Since there are 26 black cards and a total of 52 cards, so the probability there is 52, 26 over 52 plus the probability of selecting a red card. We know that there are also 26 red cards from the 52 cards. Now, since black and red cards class are mutually exclusive events, meaning it's impossible that when we select a black card, at the same time, we will be able to select a red card. So that's impossible to happen. So the joint probability between two mutually exclusive event is zero. So this is minus zero. So this is equal to 26 over 52 plus 26 over 52. This gives us 52 over 52, or the probability is 1. Meaning, the probability that we select a black card or a red card is 1. A card is shown randomly from a standard deck of 52 playing cards. Find the probability that it is a diamond or an ace card. So this is calculating the probability of selecting a diamond or an ace card. So calculating the probability, so this is working on the probability of selecting a diamond card plus selecting an ace card minus their joint probability. So probability of selecting a diamond cards, how many diamond cards do we have from a deck of cards? So by inspection, we have 13 diamond cards, all over a total of 52 cards. So how many ace cards do we have from a deck of cards? So we have 4 all over 52 cards. And their joint probability, since the two are not mutually exclusive events, we have to find out how many diamond cards at the same time ace card. So we only have one, and that is ace of diamond card. So this is 1 all over 52. The reason why we have to subtract this value, since we have counted ace cards 5 times, wherein we only have a total of 4 cards from 4 ace cards from a deck of cards. In here, remember that these 13 diamond cards, we have one ace card, and then we have 4 ace cards here, a total of 5 ace cards. So we have to less the overlapping number, which is 1. And this is their joint probability. So we have 16 all over 52, which is equal to 4 over 13. A card is drawn randomly from a standard deck of 52 playing cards. Find the probability that it is a red and a king card. So this is working on the probability of getting a red card at the same time a king card. So by inspection, how many red cards at the same time king cards? So we have 26 red cards. So from the 26 red cards, that is divided to or divided by, so we have 13 heart cards and 13 diamond cards. From the 13 heart cards, we have one king card here and another king of diamond from this group. So we have a total of 2 red kings all over 52 cards, which is 1 over 26. A card is drawn randomly from a standard deck of 52 playing cards. Find the probability that it is a black and a red card. So this is working on the probability of black and red. Since again previously I've mentioned that black and red are mutually exclusive events, therefore their joint probability is 0. A card is drawn randomly from a standard deck of 52 playing cards. Find the probability that it is a queen and a space card. So this is about joint probability. So we are asked to solve on the probability of selecting a queen and a spade card. So we have to count how many cards satisfying the condition that the card should be a queen card at the same time as space card. So from the deck of cards, we have queen, we have spade, clover, diamond, and heart card. From each suit, we have 13 different characters. And among the 13 different characters is queen. So we only have one queen of spade all over 52 cards. So this is the correct answer. Now, we will be dealing with an observed data. So, this is about a survey that answered the question, do you enjoy shopping online? So, from the contingency table here, we have a total respondents of 100. Among the respondents were teenagers, 30, a total of 50 adults, and 20 elderlies. So, the each respondent has to reply yes or no. And among the 100 respondents, 55 replied yes, while 45 replied no. Now, from this data, we're going to calculate probability. And the first question here is, what is the probability of selecting a respondent who is a teenager. So this is working on the probability of selecting a teenager. So we have to find out how many total teenagers from the data. So we have 30 all over 100. So this is 3 over 10. So the probability that as we select a respondent from 100 respondents, the chance of selecting a teenager is 3 over 10. How about the probability of selecting a teenager and an adult? So this is probability of selecting a teenager and an adult. Now, the two events, teenager and adult class, are mutually exclusive event. So it can never be that as we select a teenager at the same time an adult. So it's either a teenager or adult, never a teenager and adult. So the chance here is zero. What is the probability of selecting a respondent who did not enjoy shopping and an adult? So this is probability of selecting a respondent who did not enjoy shopping and an adult. So how many are adults? We have 50. Among the 50, how many adults did not enjoy shopping? So that will be the value of the numerator. So 25. So we have 25 adults at the same time did not enjoy shopping online, all over 100 respondents. So this is one fourth. Now, what is the probability of selecting a respondent who enjoyed shopping online or an elderly? So this is probability of yes or elderly. So this is probability of selecting a respondent who enjoyed plus probability of selecting a respondent who is an elderly minus their joint probability, yes and elderly. So the probability that the respondent to be selected enjoyed shopping online is the total of yes is 55 all over the total respondents 100 plus the total of elderly all over the total respondents less yes and elderly. So how many elderlies from the 20 who at the same time enjoyed shopping? So there are 5. So this is 5 over 20. The reason why we less this 5 because we avoid overlapping here, and this 5 is actually their joint probability. So in here there were 55 respondents who enjoyed shopping. Among the 55 respondents who enjoyed shopping, there were 5 elderlies. So the 5 elderlies were counted already. And then we counted the total elderlies who are 20. So meaning the total count of elderlies here will be 25, not 20. So instead there is an overlapping here. So we have to remove that overlapping count, which is 5, which is considered as their joint probability. So the answer here must be 55 plus 20 less 5. So we have 70 all over 100. This has to be over 100. So this is 7 over 10. So in calculating for the basic probability, for instance, calculating the probability of a simple event, the numerator would be the number of outcomes satisfying the total count of that simple event. For instance here, there are a total of 30 teenagers, so that will be your numerator. And then over the sample space. Now, in calculating for the joint probability, for instance here, you have to count how many outcomes that would satisfy the two descriptions here. The total number of respondents who did not enjoy shopping. At the same time, how many of these respondents are adults? So that would be the numerator. It's always over the number of observed data. On the other hand, when you make use of the conjunction or, like shopping online or elderly, you have to work on the sum of the two events, elderly and yes. But you have to less their joint probability if the two events are not mutually exclusive events. In the event that the two events are mutually exclusive events, so there should be no third term here since the joint probability of mutually exclusive event is zero. So I hope you were able to understand how to calculate, how to work on basic probability.